Well, you said that physicists didn't like infinity, and I'm a physicist, and I guess I have to agree with you. I don't much like infinities. When we encounter infinities, for example, in quantum field theory, we do everything that we can to eliminate them so that we can go on. And then we feel very proud that we've found a trick to get rid of the infinities so that we can continue our work. And we often deal, in my own area of research, with the thermodynamic limit. And in the thermodynamic limit, one imagines that the system goes to infinity. But of course, as a physicist, we never really think that it goes to infinity. We simply think that it gets big enough. And so what I'm wondering is there a real difference between infinity and big enough? That is, physicists often think about very large numbers as being large enough that we don't have to worry anymore that they are finite. And I'm guessing I'm asking, is there any philosophical problem that a physicist needs to worry about in thinking about infinity in that way?
Yes. Thank you to realize what physics, the infinity by mathematics and physics are different. So my point of view was clear. But the mind, the quest of the truth, it is a quest for truth, and there is no limit. And so you can see the value of the word infinite is not the same when it is a quest of intelligence and reason and the observation and the measurement of things. And the question of infinite is on all this level, but it's the same word for measurement, for quantities, material quantities, or energical quantities, formal numbers, Aleph, 0, and so on, and what is specific in mind. And that is the problem of analogy, how it is possible to use the same word for this different level. And my aim was to consider that there are relations between these three levels. The theological revolution change from Thomas von Aquin to Nicolas de Cuse had very importance for the growth of modern science.
I might add a short historical note, not with respect to physics, but with respect to the Greeks. I don't think that the Greek already had or used the term infinity. You quoted aperon, but aperon does not mean there are no limits. It means there are limits, but they cannot be reached. So that's the difference between actual infinite and potential infinite. I don't think the Greek had that term, infinity.
Yes, the classical extension, the actual and potential infinite. But I think with mathematical language, this two parts is not sufficient. And we have with Bolzano a third consideration about infinite, mathematical.
But Bolzano come back to the ideas of Aristotle, because, say, Aristotle, the first one to say that it's impossible to have an infinite in act. Yeah.
Is there an inductive process where you prove from n plus 1 an infinite process or not? Okay, well, I don't know. This is okay.
Coming back to your questions, but physicists are accustomed to infinity. If you look at the 1s wave function of the hydrogen atoms, they go up to infinity. They never end. Yeah. And there are many, many examples in physics without any end.
Physicists take derivatives, right? That's an infinite process.
Yeah, yeah.
Well, I think that that physicists often take the same view that Leibniz took, that this concept of derivative is simply small enough, that it's something of a fiction. Perhaps this is one of the reasons why physicists are not so happy to be taught calculus by mathematicians, and are much happier when they are taught calculus by other physicists.
It's a question on the Greeks again. Would you think that the choice made by Democritus on the existence of atoms was due to a refusal of the actual infinite, while maybe the choice made by Heraclitus of a continuous flow of time would be symmetrically, in a sense, a kind of acceptance of actual infinite?
It is a poem with Democritus was only fragments, but the meaning of the problem is on unity. For Aristotle and classical thought, the world is unique. Unity is the first concept. With the Democritian approach, multiplicity is the beginning of the thought. And I don't know if Democritus was an infinite universe as Newton. It was on others.
Sorry, can I say? In reality, for the Greek, for Aristotle, the finite and infinite are physical categories, not metaphysical. That is clear. For this reason, he say, finite is to say a thing to have limit, and it is impossible to have an infinite in act. Aristotle repeats these many things, because it's a problem of matter, it's a problem of physics, not it's a problem of metaphysics.
Yes, but what is the difference between physics and mathematics? It's another problem.
Because the other question is, what is the science of reference for the physics? For many, is the mathematics. And this is not for the classic interpretation, especially for Aristotle, but also for the new epistemology. For example, the Belgian Paul Ricoeur, that follow contemporary philosophy, that follow a reinterpretation of this Aristotelian approach. Because in the end, he say, the reference is the nature, not the mathematics. The mathematics could be very useful with the models to understand nature. And this was also the last conference of our former president, Cavivo, was this. This is a very important point also for our discussion. Thank you.
My question is mainly to mathematicians. Can there be situations where you have infinity multiplied by infinity or infinity divided? I assume that if infinity is multiplied by infinity, it's still infinity. But what happens if you can have such a situation when you have to divide infinity by infinity? What does this give, or it cannot exist?
I guess I must answer this. Yeah, we divide infinity by infinity, or more usually 0 by 0, a lot of times in algebraic geometry. The answer is there are infinitely many answers to that, and you just introduce a new infinity consisting of these infinitely many answers. And it's not just scholastics. For example, the famous, at least among mathematicians and some mathematical physicists, recent theory of Bridgeland about the so-called stability conditions and space of stability conditions. It's exactly treats exactly this kind of question in a very precise way, and it introduces one more infinity, namely infinity of ways of dividing 0 by 0 or infinity by infinity. And in this space, infinite space of ways, there are walls. And when you cross the wall, you get a totally new way of dividing 0 by 0 or infinity by infinity. And it has just well, practical, I'm not sure whether I can it or say it or not, but in the, for example, in the renormalization theories in quantum field theory, it's used, it's reality. So yes, one can divide infinity by infinity. Yes, one can do it in infinitely many ways. Yes, when you do it, you introduce a new infinity.
All these infinite are infinite in potency.
Obviously, we move into a direction where we could start again with the topic of complexity and completeness. Well, I should stop here and close this session. We are already rather late. We will have a coffee break now, and after that, in about half an hour, I would say, our closed session. Thank you very much.